Welcome to Hot Topics. Our subject today would be motor protection, either round down or round up the overcurrent device. So, what is the story? Many questions come in that sometimes they find that they have rounded up a device or round down. So, just exactly what are these requirements? When were they implemented in the code? Well, in the 2002 code, they allowed the exception 1 to be applied if the electrician or designer wanted to do so. But until the 2002 code, you had to round it down, and if it would start and run the motor and drive the load, then they stayed with the round down size. However, if nuisance tripping occurred, they could apply the exception 1 and round it up. If still they had nuisance tripping of the overcurrent device, they could go to the exception 2 and apply the maximum percentages in the table, which we will talk about. But notice the table 430.52 lists the percentages for the type of devices outlined in the table, but you can always round down smaller. That's just a percentage to start your design with. Now, to kind of illustrate this, I want to use our figure 18-25D as in dog in Stallcup's Volume 2 Electrical Design Book. Now, reviewing the figure 18-25D, notice in the illustration we have a circuit breaker outlined ahead of the circuit supplying the motor. And of course, we have the 430.52C1, which is the round down size, and the exception 1 to 430.52C1 would be the round up size. The percentages that we would use for say a non-fusible type fuse, or say a time delay fuse or instantaneous trip, or an inverse time is listed there. So a non-time delay fuse, instantaneous trip, and inverse time circuit breaker is listed in the table based upon the design letter and the type of motor that's outlined there. And then, of course, 240.4G and 240.6A with the tables will give you certain information. For example, 240.4G with its table will list the loads where the overcurrent device can be size greater than 125% of the full load current of the motor. 240.6A with its table will list the standard overcurrent devices that are outlined in the table. Now notice in this illustration we show an inverse time circuit breaker, and we're using the exception 1. We're rounding it up, or we're going to use 430.52C1 and round it down. Then we have your disconnect there and the overload sections that deal with overloads. Nameplate is 62 amps, and remember 430.6A 1 and 2 on page 308 and 309 respectively of the code would list when you would use the full load current of table 430.250 for 3-phase, or the nameplate current to size the overloads that you see in the illustration with the arrow pointing to such overloads. Now, with that thought in mind and thinking about that, let's move now and look at the calculation to determine the inverse time circuit breaker. Step 1, finding the full load amps, 430.6A1 and table 430.250. Now, notice 430.6A1 on page 308 and 309 will refer you over to table 430.250 on page 33 of the code. And we would find then, based upon the 50 horsepower, 3-phase, 460-volt motor, lining it up in that column, we'd come up with 465 amp. Step 2, we would refer to the table 430.52 and select our percentage. We're using an inverse time, so we won't use the column that's non-time delay with the column that is time delay or instantaneous trip column. We'll use the last column, which lists 250%. Now that is selected based upon the motor being 3-phase, polyphase, induction type motor, design B motor as we viewed in the illustration. Now, step 3, we have to apply the 250%, selected from table 430.52 times 65 amps, and we come up with 162.5 amp. Now, the application of 430.52C1 or the exception one would be applied after we perform the math. So looking at 162.5, we could round up to 175, and that's the size overcurrent device, or we could round it down to a minimum size of 150. But I would like to point out now, you can always go lower than what we see in this step 4 and 5 if it'll start the motor. We typically, as designers and installers for a circuit breaker at 600 volts or less, we use 3 times its rating. So if you had a 150 amp circuit breaker, 3 times 150 is 450 amps. If you selected a fuse, it's 5 times the rating of the fuse. So if you had a 90 amp fuse times 5, that would be 450, see? And it comes out, so the table's pretty well based upon 250% basically for a circuit breaker. So the solution is we could have the round down size at 150 or the round up size at 175. Now we would review starting on page 318, we would review 430.52C1, which is the round down size, and I'm going to kind of paraphrase it, but it basically says you cannot exceed that 250% of step 2. So the 162.5 amps in step 3 after the math was performed, you would have to round it down to 150. But now the exception 1 per 2002 NEC and other revisions after that basically states that you have a choice. It shall be permitted to round it up or you don't have to round it up. But if you want to round up, you can. So the next size above 150 naturally would be 175. Now, if it still didn't start, then we could go to the exception 2 to 430.52C and look at item 3. And if the full load current rating of the motor was 100 amps or less, and in this case it is, it's 65, we could go up to 400% with no exception to allow us to round up. It'd be a round down from size from there. However, if the full load current of the motor was over 100 amp, then we could only go up to 300%, again with no exception to round up. So the question always comes, what would we do if none of these percentages would allow the motor to start? Then you would go to 430.52C3 and you would use an instantaneous trip breaker, which is column, I guess it's maybe column 4 in the table 430.52 under the heading instantaneous trip, and you could go up to 800% of the full load current of the motor, 65 amp. If that still gave you problems, then you could go to the exception to 430.52C3, and you could go up to 1100% 1,300%, and under certain conditions of use, all the way up to 1,700%. But now notice that you have to have a reason for doing that. The exception 2 modifies exception 1 in 430.52C1. So you have to try the round down and the round up size first, and then you can apply the exception 2 if need be.